have someone helping them that doesn't have this working. Okay, we have one more. Okay.
Wherever it's saved, I would just save it somewhere differently if it's not pulling up.
So we just can't even set the working directory though.
So where is it saved? Where's the, so that's where the thing that is saved, right? In this particular folder? Yeah, so the data's right here. So we're setting that one as a, so save that to desktop, right? So I believe you're good now. So you have the data, yeah. So I set the working directory as the folder on your desktop. So that's your working directory now, and that's where the data is. So
I'm glad it was
go back
that
to
easy.
RStudio.
Okay.
So you can set working directory over here as well as typing it, and now I believe it read in your file. So
she should be able to run and get this to come up now that she's got her directory and put it in the right direction.
you can also set it here,
Okay.
but
So now that we have it read in, we can see up here that it's in our global environment.
So we set the
And
working
it tells us there's a bunch of
directory.
observations of 36
and
different
then you read in
variables.
the data here.
But how do we know what any of this is? If you type in either in the console or in your script, view, open parentheses, and then I'm going to add in the function head, which basically tells it to read the first few lines of the object. So you don't read in the whole thing, you just read in the first couple ones to make sure it's doing what it should be doing. Because this is a very large table of data. So then I'm going to start typing in, and you notice as I start typing in historical, my data table pops out. So I hit enter to fill that in, and then control or command return, command enter. And now it pops up a new window that all of a sudden is giving you all this information. So mine reads the first 6 rows of information, and then it gives you all of the columns. So yeah, you can make sure that you're actually reading in what you want to read. Now this data did come straight from the NCDC, so there's a lot of stuff that we need to clean up, which is the next few steps that we'll do. Let me make sure we're not missing anything over here. Right. So we now have our data read in, but it doesn't have column names. It just has, this is column 1, column 2, out to 36. There are specific columns that we don't need and ones that we do need. So these are the columns that we're going to want to use. These are 2 identification ones. This tells you the for each observation what the year, month, day, hour, minute is. It gives you latitude and longitude, and elevation, the call letters of the station, as well as some atmospheric data. So we're going to pull in this data into, or pull it out and give it names so that we're just using the data that we want to use at this point. So how we do that is going back into R, and so if we look at this, back at the view data, we have this extra variable at the start that literally is just giving us the row number that it's on. So we don't need that one.
So I couldn't find this table.
Oh, yeah. So you do view head, yeah, and then do command and return. And that'll run the, there you go. Oh.
Peter, that's supposed to be a capital V, right?
Yes, it is supposed to be a capital V. Yeah. Procure environment. Okay, so it's still not reading it in. Yeah. Okay, you say your working directory. Go ahead and try running the historical. Historical. Yeah. Try command. Yeah, running that again. Okay, so we don't need that first column first of all because it's really just telling us the row number. So the way that you can remove that from your data, if you go back to your script Oh, with the viewing?
Yeah. Just make sure.
Okay.
Think about it.
Okay. So to remove that first column, you're going to replace, you say, okay, we're going to replace this object with the same object, just minus that first column. So you're going to say historical climate Phoenix gets the historical climate Phoenix, or you can mistype, open bracket. And so the brackets mean that you're going to call either a specific set of rows or a specific set of columns from this data table. So we want all of the rows, so it's a row comma column format. So we're going to say, by leaving this space, by leaving this blank, we're saying pull all the rows that are from this object. And then we're going to fill in on the other side of the comma the number of columns that we want. So we want columns 2 through column 36. Does that make sense? Bracket, comma, 2, colon, 36. And then it'll close the bracket. And so what we're saying with this function is we want to replace historical climate Phoenix with the 2nd through 36th columns of historical climate Phoenix. So we're basically removing that first column, chopping it off, because we don't need it at all.
But like comments or
Run that, and notice now in my global environment, we only have 35 variables in there. So we dropped a variable.
very cut
Does that make sense?
let me see if shift. No, it's not with shift. No.
And that's set up row column.
Yes. Brackets are in R are always row, comma, column. So that's just how, that's the language of R.
My keyboard, it should be.
Change the name of the data or anything?
Okay. Yeah.
So I have the same like as yours.
Oh, you have curly brackets. That's the difference.
Oh, so you don't with
No, yeah,
the
it's
so
a
you
normal
have-
bracket.
Okay.
Oh, sorry, no. Do without the shift, just do bracket. Yeah. I frequently actually hit the shift because I do that so often, and then I found it was $0. Okay, so now we've gotten rid of that basically useless first column, but we still need to get the exact columns that we actually want. So to make sure that we don't completely lose that other information, even though we don't need it right now, we may want it later. So we're going to create a new variable called kphx, which is just the weather station code for Phoenix. So if you ever see that on weather data, that's what that is. kphx gets historical climate Phoenix. So, and then you're going to do the open bracket. Make sure it's not the curly one, just the straight bracket. All of the rows. And then this time we don't need all of the columns, we need a specific subset of them. So to create lists of numbers or vectors or whatever, you use C, open parentheses. So C basically means list. So you're creating a list of numbers, characters, variables using that function. And we want columns 2 through 8, as well as, so put a comma there, 10 and 11, 13 and 14, 29, 31, and 33. So this is just basically telling us we want these specific columns. These specific columns correlate with the date, the time, the month, the year, the location, elevation, and atmospheric data. So then you would run that. You're doing basically the same thing that we just did,
The working directory.
only creating a new object with it. So now that I've done that, I have a new object. And it's the same number of observations, but with fewer variables.
B.
And it has a new name.
It's always a dumb spelling mistake. Always.
Does that make sense?
Can it still count?
Cool. Okay, So now we want to actually name those. So the way that you name columns or rows, but in this instance we'll just do columns for a data table, is by using the function call names and call names of your object. So call names open parentheses kphx close parentheses gets, and then we're going to create another list, but this is going to be a list of column names. So all of these names need to be in quotation marks so that it knows that these are just characters. It doesn't need to actually read the information inside of it. It just automatically puts all that information into the column. So our first one is the first ID, USAF. Second ID, UBAN. Make sure you put a comma after the quotation mark and before you go on to the next column. The commas distinguish different columns
It is really short. Is that filled in?
in the function.
Oh, you guys have been trying a different data set?
No, we just named
So then we're going to do year, month, day, hour,
Back to our studio though.
minute.
Let's go back to our studio.
Alright, so we do latitude.
Okay.
Yeah, we need Zoom, right?
Yeah. I can't see
We're on the
the
first
far
row, I can
object.
see.
Longitude.
On this row.
Don't worry, you know what? It's fine.
Then we have elevation.
There we go.
Oh, what was the mistake?
I have no clue, and sometimes that's the answer to these things, is that some finicky thing in there doesn't work, and it's all about troubleshooting, but it might take us help at work. It's still reading it. I did absolutely nothing. I just set the working directory again and again and again, and it just decided.
Wow.
Well, it's still not reading it. It's reading it right now, but it's not done reading it. So it might work. Give it a second.
Okay. So this
If it
really long
doesn't
string is
work,
just
it
telling it
terminates,
what you
try
want
it
the
again.
different variables
This thing needs
to be called.
Okay.
The colon.
Oh, yeah, cool.
Oh, columns. It's telling it you want to name the columns of this data table.
Just name the same as
Yeah.
What was the?
Slightly different. Call would be, it has multiple functions. One is colors, but call is also just like what is the column itself.
C is
Oh.
I changed it again.
So one way, if you want to keep it all like in the same window, you can hit enter or return within the script, and it'll bring it down. Does that make sense?
Naming things is not gonna be it's just function.
Did it work? Okay.
So then you can highlight those two, or one or two, because it's the same line of code. I just broke it in half so you could read it all in the same window.
You can write down the script.
Oh, I can do that? Yeah, I would.
Yeah, you can write down all the script.
Yeah.
While you were talking.
Okay.
Let's try this one more time. Let's see. Let's see.
There is no bracket. And these functions are going to be something we put in
We're
every
gonna
time.
do later, so you don't need them every
So
time.
if it-
Those are gonna be done later. Give it another shot, and if it doesn't work, just type in down his code, okay?
I'm the last one trying to run the columns.
Yeah, just a little.
So you need to make sure you've run this one first.
The
one
KPX?
before it. Yeah, make sure that one ran properly.
Yeah, I think it won. Maybe, should I like check through
Okay.
all of them?
Okay.
No, you don't need to read all of
Can you guys see
them.
better now?
But
Okay.
double check.
And I can scroll.
Which I don't think it did.
Why don't you just,
So make sure that this one ran. Error, unexpected error. So double check that the code is right there. It looks like you're missing a comma here. So there's always simple things, like most of the time it's little things like that. Looks like there might be something else wrong though. Let's see. So yeah, your code, let's see, you want 2 through 8, 10 through 11.
Okay, so you can then run that.
14, 20,
29, 21, and then again you didn't have a comma here. So let's try that again, see if something, yep, that ran, and then you can run the next one.
And then to see
So,
if it
yeah,
works,
so you need to make sure that ran, and so
you
it's
hit
just
view,
missing some very
head,
simple comments.
and then that file again.
Oftentimes the problem.
And you
So
run it,
double
and
check
then
when
it'll
something
pop
doesn't
back
run,
up.
do some troubleshooting.
So now we've
Make
taken
sure
that
that you're
huge
not
long
missing any
so there should be a comma.
file
separating
of
every-
36
Everything,
variables.
every column
You
that you
condensed
want to
it down and
find.
renamed it, so we now know what all of our
With a
column
comma.
So
headers
this
are.
is saying that you want to find 2 through 8, and then also
Let me
10
flip
through
back
11,
to the
and then
code so you
13
guys
through
can see
14,
that.
and then 29 and 31 and
Yeah.
so there's a comma separating all.
I'm gonna try to run this and then.
Yes, and then that one should run.
Does this make
Yeah,
sense?
it runs.
Okay,
Thank you.
Does it work?
I missed the comma.
Cool. Okay, so now we've gotten them renamed. Now, it's kind of frustrating because of the way that it was imported. You have your year, you have your month, you have your day. We don't really care about all of them individually. We want them collectively because it's a lot of time that we're looking at. So we want to combine those three into one column called date. To do that, go to a new line in the code, and you're going to type in kphoenix, and you're again telling it, put this data into the data table called Phoenix. And we're going to use the function called unite, open parentheses. Now, I will say really quickly, if you know of a function but you don't know how it works, you can go into your console and type question mark, the function, enter, and in this bottom right window, never let me pull it over. There we go. There's this help feature, which is fantastic. It pulls the documentation about that function. So it then tells you, okay, what does it do, the description, it gives you the usage, it gives you the specific arguments within the function. So if you're ever using a function like, I don't remember what all needs to go in this or how it's formatted, you can just type in question mark function and it will tell you that. So we're going to use unite to combine these columns into a new column. So unite needs to know what data you're looking at. And we're going to look at kphx. We're going to create a new column called date. Note that we have quotation marks again so that it knows this is a character and it's not trying to read it as like some sort of function or anything like that. Comma, so next argument. The next set of arguments are what are we trying to unite? And in unite, you can combine multiple columns at once. So we're going to go and we're going to do the day. The day, the month, the year. So we're going to combine all of those three together. And so in the function, it keeps reading these as columns until you use the SEP function. SEP stands for separation. And so what you're telling it is combine day, month, and year into a new column called date, and these are going to be separated by something. You're going to put a quotation marks because you want it again to read it in that way. We're going to do a backslash. Good there? The default for this means this phrase. So default for this function means you add this, it'll do this automatically, but I just do it, I write in the code so I know what I did there, whether or not I removed columns. This will tell it that when it creates this new date column, it will remove these 3 dates from the table. So you're basically condensing them and removing them, and then you just have that one column instead of 3. You could say remove equals false, and it would leave them in there as their own distinct columns as well. But for our purposes, we'll just remove them. So then run that function. Oh, yeah. Yeah, so if you ever are working in R and you're thinking, ooh, I don't know what I need to make a note to myself about why I did this or why I didn't do something. Notes within R are started by a pound sign. So I can just say to myself, removed day, month, year, and placed within date. And because it has the pound sign in front of it, it should come up with different colored font on yours.
Usually green.
Is green?
Usually green if this is the format that you have, it changes color based on your background. But when R then runs the whole script, it just skips over any lines that have, or any characters that are past a pound sign on that line of code.
This is really great when you have collaborators.
Yes.
'Cause then you
So they
can-
understand what
this
you're
is
doing?
what I'm doing
Right.
with each of these
Yeah,
steps.
so you can make notes within the code using a pound
So
sign.
it's not code, it's a note. It's an
Right.
Okay.
They call them comments.
Comments.
Yes.
So let's.
But it's within your script, but then when you run the script, it doesn't R doesn't try and run anything that has that
Oh.
And usually
signifier
I
in front
place
of it.
it before whatever I'm about to do.
Yes.
So I write like removing like columns that I don't need, like pound sign remove columns I don't need, and then have the lines of code where I remove.
So it could be helpful for yourself or for others.
Yeah,
Okay.
it's,
Right.
it's honestly for me.
That's usually what I
Because I
do.
don't remember why I did it.
So
Okay.
let's go back and check
And
our data table to see if it actually worked. I do this a lot with my work. I constantly am checking the first 6 lines of whatever table I'm in to make sure it did what I wanted to do. So now, we no longer have day, month, and year, but instead we have January 1st, 1976 as the first 6 columns. So now we have the date all by itself.
can you go back to the
Yes.
Can I see how you?
Give it down.
Your-
Anybody need help with Unite?
Yeah, it doesn't look well.
Where do we guys have it?
Do you have the date column there?
No, so in the unite
run it
column,
one more time?
in the unite function, because I said remove equals true, I've removed the day column itself, but it's now within the new column date. So the third column now is replaced
Rerun this.
the day, month, and year columns with date. So you have all 3 in the same column now. And you could do the same with like the hour and minute if you wanted, and then have it distinguished by like a colon or anything like that. Okay.
It doesn't know if it's correct, but I
Can you rerun these numbers? I'll just run over it. Looks like this you never got around to running because it wouldn't, if you'd already loaded in this line.
everything is working till here.
Yes.
Before that, it's working.
So the function.
My table
is a part of one of
So
those.
I have more
And it
done
looks
some
like you just had
terribly wrong.
a couple lines where it happens. I'm still trying to get very confident that you didn't get it there.
I run everything. Is there a way like to double check that? To check that I mean, but yeah, I run everything after I keep with one line and then what happens. Right. So usually what it does is it'll like run it. So it looks like that it ran that.
So we got that installed.
So should I like
Go to your packages.
should I like try to run it again?
Yeah. Something I'm missing.
Okay, so that means I think it has successfully ran. We just get so do the so they can do line, but so between view and no, do it down the bottom.
Yeah, so what I'm doing now is basically putting this stuff physically on your computer. And then to actually use it, you have to, it's like activating it. So this, now that we use this, we'll never have to use again on this.
Yeah.
Call it.
Now,
Well, I mean, they're all. There we go.
There we go. Okay.
Yeah. It's not so much like what those go label because it's just reading the character strings, but you have to have 14 of them.
Yeah, it did run. It
That
just
was it.
ran.
okay, so let's see what happens.
There's something missing in one of these, and I don't know what it is.
At least we have a different error. That's always a good
Okay, so 20. Okay, got that.
Yeah.
Okay, so this is my guess of where.
I will say right now that I will post both the PowerPoint as well as this code. I can share it with you guys so that if stuff doesn't make sense or we don't get through it all, we'll share it so you guys can at least see all the way through like what I was going toward with all of this stuff.
So if you go, so remember how we did up here, if you copy this code and change that.
Air temperature.
Yes, then you can
Point.
Yeah.
here.
And then you can close parentheses.
This is
Yeah.
Yeah.
You gotta kind of know your data a little bit. Sometimes I have like idiocy files that I'm like make sure I'm thinking of the right
undo. Hey, we got it. So I think the issue is that you had here an exclamation point. So I like this. Everything. No, but you needed to get the unite function first anyway. So.
No, I guess it's view, right?
Yes.
Right? So this goes.
Okay.
Yeah.
But I have to put this code in the beginning.
You can do it either way. Usually the space though is reserved for something you might do over and over again. Because that's just like a diagnostic on it.
So
KPX? Yeah.
at this point we've kind of worked through some of the basic cleaning stuff. To kind of shift into more of the plotting and the statistics side of it, there was some other stuff in terms of how to remove error messages within your data. Like for some reason they wrote like 999 to say that there was no data for this date or this time or whatever. There are ways of removing that, which I will post online. But so that we can get to plotting and statistics, I'll jump over that and we'll use a different, it's a tidyr function. Yeah, make sure it's got tidyr installed. So we're going to read in the other set of data that's already been cleaned. Because I wanted to show you guys how to clean stuff, but I also wanted stuff that we could actually play with. So, so this new set of data, so I'm going to make a note to myself saying, moving to new set of data to plot. So this new set of data is a longer time period that it's been cleaned, basically. So we're going to call it daily max min because that's what it is. Read CSV. The name of the file, I believe, is what should be what I shared with you guys of daily max min underscore 1933 to 2017.
So this is the other file that you sent.
Yes. So this is that second file. It should have, unless you guys change the download name, it should have this as the name and then assuming you stored it in the same spot as the other one. So read that one in using the CSV.
Daily max?
Yeah.
Header?
You can,
Thank you.
or you can choose not to. I'm gonna double check to see, to show you guys that it should have read it in just fine.
Sometimes it doesn't.
Yeah, sometimes it does, sometimes it doesn't. So I'm gonna check it by doing that, and it read it in fine. So this set of data only has your date, a maximum temperature, and a minimum temperature. And this data set goes back to 1933, and this is the data we'll use to plot and do some statistics with. Did everybody read that in well? Did you get that to work? It should have run a little bit quicker because there's less data in it than the other one. Okay. So let's check out, it's technically statistics, but it's also a way of plotting. So let's do a histogram of the maximum air temperature. So hist is the name for the function histogram in R. Since R was based in statistics, a lot of the base functions have statistical names to them. So we want the histogram of this file, specifically the Tmax column, temperature maximum. And then run that, and it should pop up in your bottom right corner. It should pop up with a plot of your histogram of daily max min $Tmax. $sign in R is how it defines the column names. So you can call it, if it's a data frame in R, then you can call it using, you can call specific columns using the $sign.
Is it the same function as C?
It's only useful, it only is used when it's a specific data frame. C would be, you would be naming it or calling it based on those. Typically, once you're trying to pull specific things, though, you would either call it by its number within the column number, or use the $sign in the name. So the C would be helpful in naming those things when you do like call names. But then after that point, you don't need the C anymore. You just do $sign, and it will, if it's a data frame, it'll remember what the different column names are. So as you're typing it, it'll suggest different ones for you. All right, did everybody get a histogram?
Not yet.
No? Okay.
Working out.
So basic statistics right there of getting a histogram.
Really? I don't think you have the file. Do you have this file CSV saved in your directory? You need to have it saved in the directory where you're working, the same place where you saved the other file. Can I see? Sure. If you open the folder, can I see? Yeah.
Okay. So
Did you read it
next,
correctly?
let's
Can I see in the?
plot the data.
Oh yeah.
So that's not plot. Here we go. So plotting it will allow us to actually look at the data itself, not just seeing, okay, we had over 2,000 data points that were like 18 or 19. Yay, but we don't actually get to see how this changes over any other relevant framing. So if we do plot daily max min, in plot you have the first argument is going to be your x variable in plotting, and your second argument is going to be the y variable. So we're going to first do the date, so that we basically look at a time series. So date will end up being on your x-axis because of the way that we're setting this up. So put the date in first, and then daily max min of your maximum temperature is the y. So we should see over time on the x-axis and temperature on the y. Okay, now we can get a little more fancy with plotting. So I'm going to give it a label for the x, which is time. or date, either of those work. These are also not necessary, these are optional arguments within the plot function. So xlab means what is the label for the x-axis. Ylab is what's the label for the y-axis. So this one is a little bit fancier. I need to make sure that I write it correctly. Since I'm trying to stick the units in as well for the temperature because there are multiple types of units, I want to be able to throw in like a degree symbol. And so the way to do that is to use the expression and paste functions in R. So air temperature So then main is what you title the title for the graph, basically. We'll say max. Okay. But that is a typo. Okay. So then run it. Okay, so it's running right now. I think this should actually mess up on purpose. Let me slide over just a little bit so you guys can see. You guys get all of that? Okay, so note that it finally ran it, and it should pop up here, but it didn't. What should be the error, because I did this earlier, is that we need to actually define the date column. There we go, it actually worked. Yay! So here's the max temp over the past 80 years. But it has weird notations. Like why is there a bunch of 2009s and 2005s? That doesn't make sense. Part of that is because it's not actually reading the date column as a date. So if you go back into the code and you tell it to look or replace the date column with a new date column that is going to be redefined by the as.date function. You're going to use the same column, we're just going to tell it to read it in a specific way. Okay. So this function is R's way of handling, Excel has its own way of understanding dates. R has its own way as well. So when you do as.date, we're telling it, looking at this column, we want this column to be read as day, month, year. And so when it does that, you replace it back into the same column as before. So then it'll read that column as a date column instead of just a bunch of numbers with backslashes through it. Does that make sense? Okay. So now, if we plot this again, it should go a little quicker. And now it has problems with the size.